Introduction to Design Guides. The aim of this section is to discuss the role of standardization in the domain of interface design. Standardization can be viewed as a way of ensuring that good human factors are incorporated in a system. For interactive system designers, designing systems with maximum usability is the ultimate goal. A good design mainly results from knowledge and experience of the designer, and more importantly, the way they apply this knowledge into a specific design. In order to increase usability, two kinds of design rules, standards, and guidelines, can be applied into a design. Let's see the difference between standards versus guidelines. The difference between these is that standards are high in authority and limited in application, whereas design guidelines are low in authority and are more general in application. The best user interface guidelines are high-level and contain widely applicable design principles. The designer who intends to apply these principles should know which theoretical evidence supports them and apply the guidelines at an early stage of the design life cycle. See the diagram. Design rules, in the form of standards and guidelines, provide designers with directions for a good and quality design, with the intention of increasing the usability of a system. Software companies produce sets of guidelines for their own developers to follow. These collections are called house standards, sometimes referred to as house style guides. These are more important in industry, especially in large organizations where commonality can be vital. There are two main types of style guides: commercial style guides and corporate style guides. Hardware and software manufacturers produce commercial style guides, and corporate style guides are developed by companies for their own internal use. The advantage of using these guides is to enhance usability of a product through consistency. Though commercial guides often contain high-level design principles, in most cases, these documents are based on low-level design rules which have been developed from high-level design principles. If an organization aims to develop their own corporate style guides for software, generally, the starting point will be one of the commercial style guides. Moreover, many design style questions have to be addressed more specifically when developing corporate style guides. For example, how should dialog windows to be organized? Which styles, color, and fonts, etc., should be used? The roots for design rules may be psychological, cognitive, ergonomic, sociological, or computational, but may or may not be supported by empirical evidence. Let's see about the design principles. Dix et al. 1998 split the design principles into three main categories: learnability, flexibility, robustness. Click on the ellipse to see in details each categories. Learnability principles are concerned with interactive system features, which aid novice users to learn quickly and also allow steady progression to expertise. The principles discussed below support the learnability design principle. Learnability divide in 5 parts: predictability, synthesizability, familiarity, generalizability, consistency. Predictability. This interactive design principle requires a user's knowledge of interaction to be sufficient to determine the outcome of present or future interaction with the system. Two aspects of synthesizability are immediate honesty and eventual honesty. In general, these principles relate to the ability of the interactive system to provide the user with an observable and informative notification about the operation state changes within the system. The familiarity principle is concerned with the ability of an interactive system to allow a user to map prior experiences, either real-world or gained from interaction with other systems, onto the features of a new system. Generalizability. This interactive design principle provides support for users to extend knowledge of specific interaction within and across applications to new but similar situations. For example, cut copy/paste, operations within Microsoft Office applications, use of same shortcut keys. To support generalizability, consistency is essential and is probably one of the most widely applied design principle in user interface design. Consistency between application is always favorable, however, consistency within an application is essential. Flexibility in interactive design extends the way a user and the system exchange information. By applying flexibility principles to an interactive system design, designers aim to improve a system's usability. Flexibility is divided in 5 parts: dialogue initiative, multi-threading, task migratability, substitutivity, customizability. Dialogue initiative. When the system controls the dialogue flow, the dialogue is said to be system preemptive. Conversely, when the flow is controlled by the user, the dialogue is said to be user preemptive. In general, a user preemptive dialogue is favored, although some situations require a system preemptive dialogue. Multi-threading. Within a user interface, a thread can be considered a part of dialogue that allowing a task to be performed. Multi-threading within an interface provides support for multiple tasks to be performed at one time. Multi-threading can be described as concurrent or interleaved. An interleaved system permits work on a single task at a given time. The word processor allows multiple documents to be open, but only one can. Task migratability means passing responsibility of execution of tasks between user and system. A computerized spell checker is a good example to this. Substitutivity offers a user alternative ways of specifying input or viewing output. Indeed, the distinction between output and input can be blurred. Customizability. The user interface should be able to support individual preferences. For example, standard control bars in MS Word can be amended as required. The robustness of an interface design can be measured in terms of the following 4 principles. These principles aim to support users to achieve their goals: observability, recoverability, responsiveness, task conformance. Observability should provide users with an ability to evaluate the internal state from its representation. If a user cannot understand the internal state of the system, there is a high likelihood that the user's confidence will be very low. Recoverability. Users should be able to reach a desired goal after recognition of errors in previous interaction. Error recovery can be achieved in 2 ways: forward negotiation and backward undo. Forward error recovery involves a user accepting the current state of the system and negotiating from the present state towards the required state. A backward error recovery mechanism within a system allows a user to undo the undesired outcome of the previous interaction by returning to a previous state. Responsiveness is usually measured in terms of the rate of communication between the system and a user. Response time, indicating change of states within the system, is important. Short duration, or instantaneous response time, is more desirable. When an instantaneous response cannot be given by the system should be able to indicate to the user that the system has received the request and in processing an appropriate action. As illustrated in the above picture, clicking the print icon on the Microsoft Word menu does not give feedback. For example, especially novice users may end up pressing the print icon a number of times. As well as response time of a system, consistency or responsiveness is also desirable. Task conformance. There are 2 aspects of task conformance: task completeness and task adequacy. Task completeness is concerned with whether a system is capable of supporting the entire task that a user wishes to perform. The task adequacy is concerned with addressing the user's understanding of these tasks. It is necessary that an interactive system should allow the user to perform the desired tasks as defined during the task analysis.